In case you're not familiar with summarization, I'll explain its benefits in this lesson. By the way, I borrowed this presentation from my IP addressing Zero to Hero course. You can find it in my profile. Let's take this network as an example. The part in the rectangle is a local area network connected to the internet. We see that the IP addresses used inside the LAN are consecutive. If we look at the subnets used here, we'll notice that there are no breaks. We've used the ranges one after another, and there's nothing in between. The one subnet outside of our LAN is 7770, which makes it unrelated to these ranges. Now, if we were to look at this LAN from the internet, we wouldn't really care about these specific ranges. By the way, let's ignore for a moment the fact that 192.168 IPs are not visible on the internet. It's just for the sake of this example, okay? Let's imagine some router out there on the internet that needs to know all the world's IPs and remember where everyone is at. It would be much easier if that router didn't have to remember routes to each of these subnets here separately, but have a single summary route to all these subnets all together. For example, it would be really nice if we could just say all the IPs that start with 192.168.1 are inside this LAN. Well, the problem with that is that the ranges inside this LAN only go to 192.168.143. That's the last IP in here. We have this subnet 192.168.140/30, and if you calculate what's the last IP in that subnet, it will be 192.168.143. Now, if we used this /24 mask, it would mean that all IPs with fourth octet being between 43 and 255 also belong in this LAN, but they don't. What if a subnet, let's say 192.168.128/30, is out there somewhere on the other side, outside of our LAN? In that case, it would be very wrong to summarize all these subnets in this LAN with this range. Let's fix that. We want to find a more specific mask to make sure we only cover those subnets that are actually in this LAN. One thing's for sure, all of the subnets inside this rectangle have 192.168 in them. So that part is for sure in. Same for the third octet, which is 1. To figure out the fourth octet, we're going to use binary numbers. We already established that this part, the first 3 octets, just a second here. Okay, so this underlined part, the first 3 octets, will be part of our summary IP. All the zeros in the fourth octet are actually the very first IP we have in this LAN. So that's this range right here. The very last IP we have in this LAN is 192.168.143. And that's what's depicted here in binary format. In order to create a summary IP address, we will take all the bits to the left that are the same in all subnets in this LAN. If you were to write all the IPs in all these subnets on a paper in binary format, you'd see that the first 3 octets plus these 2 bits in the fourth octet are the same. Next, we take all those bits that are the same in all subnets, and we use that number of bits as our new subnet mask. And that, my friends, is how you find a summary IP address. I'll do another example before the exercise, so see you there.